This is what this fellow will write. Upward force N is balanced by downward forces MA plus MG, where MA is the pseudo force. And then he will say that I don't see the block accelerating because upward force balances the downward forces. This pseudo force is given by mass of the thing multiplied by acceleration of the observer as seen by inertial observer. Where is inertial observer? Here is Mr. Newton, inertial observer. So he says that the acceleration of this fellow is A. And it is this A that has to be multiplied to M to get the pseudo force. Right? So A is the acceleration of this observer with respect to inertial observer. And A is also the acceleration of this block for the inertial observer in this figure. But for this observer, acceleration of the block is 0. The block is not accelerating for him. When the observer is moving in circular path, then the observer is non-inertial. Why? Because if anybody is moving in circular path, then whether or not speed changes, direction of motion is bound to change, whether it is uniform circular motion or not. Direction of motion is bound to change. So any type of circular motion implies that there has to be some acceleration. And if there is some acceleration, then anybody who is involved in that motion must be non-inertial. So such observer has to apply pseudo force, and only then Newton's second law is safe to use. If we talk about uniform circular motion in which speed does not change, then the acceleration is towards the center. This is for uniform circular motion. When the speed does not change, only the direction changes of velocity. Magnitude does not change. In that particular case, which is a simplified case of circular motion, acceleration is towards the center of the circle. So anybody who is sitting here or here or here or here is going to experience acceleration towards the center. Somebody sitting here will experience this. Somebody sitting here will experience that. And therefore, if somebody sitting here wants to apply Newton's second law on somebody, that somebody could be somewhere else also, or that somebody could be here also. Say two friends present in the same thing. One friend applying Newton's second law on the other friend. So, in this case, there has to be a pseudo force. Pseudo force must be away from the direction of the acceleration. So if this is the observer and that observer is looking at another observer or another particle, then the pseudo force must be in this direction. And the pseudo force is given by mass of that thing under consideration, that particle, let's say, multiplied by acceleration of this observer. And this acceleration is actually towards the center. So here it is ma in opposite direction to the center. Away from the center it will be. It is a non-real force. And this force is called, this pseudo force is called centrifugal force. Centrifugal force. That's the name of this force. It is given a name that itself shows that it must be coming again and again and again. It must be used quite a bit. So it is assigned a name. But note that ma is due to the observer. ma is not a force which has some origin like electromagnetic or gravitational, and somebody who is at inertial frame will not say that there is anything like that. So if you are watching from here, you will never say ma is some force acting away. You don't know about ma if you are an inertial observer. Wrong application of this thing can lead you into this trouble. Wrong application I'm talking about, right? Some student is analyzing some particle's motion which is going round and round and round. And speed is constant. So it is uniform circular motion. Now that student knows that for uniform circular motion, direction anyway changes and therefore acceleration has to be there, and this acceleration is towards the center. Let us say he uses A to show that acceleration. That means, according to that student, there must be some MA force giving A. Without some force, you can't be accelerating. You can't be accelerating without a force. So because there is some A towards the center, there has to be some force. Okay? And then that student says that there will be a centrifugal force M. The two forces cancel each other. So what's wrong in this thinking? MA on the right side is the centrifugal force. MA on the left side, it is also called centripetal force, by the way. That MA, this acceleration A is called centripetal acceleration because it is towards the center, so centripetal. It is always towards the center for uniform circular motion. So centripetal acceleration. So A is centripetal acceleration, MA is centripetal force, that MA is centrifugal force. Centripetal force and centrifugal forces cancel each other. What's wrong in this thinking? If anything is wrong at all? Well, the problem is, who is your observer? Inertial or non-inertial? That's the problem. If your observer is inertial, then he doesn't know what is centrifugal force. And right side force is centrifugal force. MA on the right side is centrifugal. It does not exist for inertial observer. Because Newton's second law does not work for non-inertial observers, and we want to make it work, that we have to introduce the concept of pseudo force. Otherwise, pseudo, you know what pseudo means in English language. Otherwise, it is a non-existent force. If it is non-existent, how can you show it for all cases? You cannot show it for all cases. If you say that my observer is non-inertial, then yes. But in all cases, you can't show that type of force on the right side. And there is one more thing. That acceleration A is there because of some other forces. So somebody is actually providing that centripetal force. Somebody is providing this centripetal force. Centripetal force may have various origins. Say, for example, Earth is revolving around Sun, or some satellite launched by ISRO is moving in circular paths. Why does it move in circular paths? Because centripetal force is provided by Earth's attraction force. So because of Earth's attraction, there is centripetal force, this fellow. Likewise, when we talk about Earth revolving around Sun, then we will say that Sun is applying some gravitational force on Earth. Because Sun applies gravitational force on Earth, that force provides the centripetal force, without which how could Earth go round and round? So somebody always provides this centripetal force. It could be gravitation sometimes, but not always. If you take a string, a stone tied at one end, and you whirl the string, so a stone rotates in a horizontal circle. Or you can even make it vertical, like that. Now here, there is tension in the string. That plays part in providing that centripetal force. So somebody provides the centripetal force. It has to have some origin. We have talked about 4 origins. Gravitational, electromagnetic, nuclear, weak. That's it. Only 4 origins are there. One of these 4, or a combination, must provide centripetal force. Sometimes gravitation provides, sometimes electromagnetic force provides, sometimes it can be a combination of these 2. Jointly they help and they jointly provide it. That's the story of centripetal force. Somebody provides it. It does not have an origin of itself. It is not born on itself. Somebody else is born, and that somebody else is providing it. But the force on the right side, that MA, that has a different story altogether. It doesn't have any of those 4 origins. It is a non-existent force for Newton and for anybody in inertial frame. Anybody in inertial frame, it is non-existent, 0, absent. But it is there to take care of the correction, so to say. In Newton's second law, or I should say to make Newton's second law work, to make this Newton's second law work for non-inertial observers, that is pseudo force. And in the context of circular motion, that pseudo force is so commonly encountered or discussed or talked about that it is assigned a dedicated name. Centrifugal force is its dedicated name, but it is itself pseudo force. So one should also not say that there will be centrifugal force, there will be pseudo force. That's another problem. Don't make two forces, they are one and the same, pseudo and centrifugal. And they are both non-existent for inertial observers. Consider a car accelerating towards the right side. It has got a pendulum attached to its ceiling via a light thread. What angle will the string make at equilibrium? What angle will the string make at equilibrium from the vertical? We can solve this question both ways, choosing inertial observer or choosing non-inertial observer. Let's choose non-inertial observer. This observer is also accelerating with respect to inertial observer. And therefore, this observer will apply pseudo force MA to the left of this. Earth will apply mg, which is gravitational force. Due to the effect of these two forces, the bob will go in this direction, leftwards. Leftwards it will go. So we would expect that the equilibrium would be somewhat like this. And we want to know the angle from the vertical. Let it be theta. For this observer, it will permanently look here. This bob will permanently look like this. So this observer will say that the bob is at rest. Bob is at rest. Bob is not accelerating. So the net force on the bob of the pendulum should be 0. So this observer will say that there are two forces. One is the pseudo force and other one is the gravitational force. And in fact that I should have shown here also. So let me correct it. Tension is also there. This is a string. So tension is there. Tension is there now also. These three forces should add up to give 0, because for him the bob is not moving at all. Choose two directions and break all forces. So I am choosing these two directions. Can you tell me the component of T in this direction?
Sir, to the right side it would be T sine theta.
T sine theta. Since it is equilibrium, dividing and therefore theta is tan inverse A by T. Any questions? Let me know. This answer will not change if you do the same problem from the inertial frame. Okay, now tell me this. Suppose you have got the pendulum hanging from the car's roof and car is going quite fast, but it is going with constant velocity. It is going with constant velocity, but it's quite fast. What angle will the string make from the vertical?
So 0 degrees.
0 degrees. 0 degrees is the right answer. It is the acceleration, not the velocity, that matters.
Sir, 0 degree since
That's your assignment question. We stop now.